During this lesson you will be required to fill out a worksheet. I recommend you read through the worksheet before viewing the lesson. In order to give you time to do this, you can use the pause button at the bottom of the screen. Building materials, concrete. Properties of general materials used in construction. Learning outcomes. By the end of this lesson you should be able to 1. Give an example of where concrete is used in the construction of a building's fabric. 2. List the main components of concrete. 3. Give a brief description of one characteristic of concrete. And 4. Describe 2 common tests that are used for concrete. Concrete. Used extensively within the building industry, it is a mixture of cement, water and aggregate which takes the shape of its mould, and when cured or set at a suitable temperature and humidity, it forms a solid mass. In the image on the bottom left hand of the screen we can see an example of some fresh concrete being poured on site, and in the image on the bottom right of the screen we can see an example of a paving mould that concrete can be poured into. Concrete systems used. There are 2 ways concrete is used to create building products. The first is called cast in situ, and this is the phrase that's used for when we're talking about fresh concrete that we pour on site. Or 2 is precast. This would be made in a factory. In the image in the bottom left hand of the screen there we can see an example of cast in situ concrete being poured on site. That's where a pad foundation is being poured. And then in the image in the bottom right hand of the screen we can see an example of some precast concrete lintels for bridging window and door openings. Concrete uses. So number 1 there, cast in situ and precast concrete can both be used in order to form foundations for buildings, floors and walls of buildings, the building frames, roofs, windowsills and beams. We can see in the image on the right hand side there at the top of the screen an example of a concrete windowsill. Number 2 there, precast concrete can also be used for creating blocks and bricks. We can see in the image on the bottom right hand of the screen there an example of a concrete block. The nominal sizes of concrete blocks are 440 millimeters long by 215 millimeters high by 100 millimeters deep. And then it can be used for bricks also, which are standard sizes are 215 millimeters long, 102.5 millimeters deep and 65 millimeters high. So worksheet, question 1. Give an example of where concrete is used in the construction of a building's fabric. Composition of concrete. Concrete is a mixture of cement, which is the matrix, and we can see an example of cement in the image on the right hand side there. It's in the, we see it in somebody's hand there. It's a grey powdered substance. It's also a mixture of water. It has to be added to the mix also, and this is the catalyst which sets the chemical reaction into play. And then number 3 there also aggregates, which are the filler. So concrete is a mixture of cement, water and aggregates. We can see an example over on the right hand side there of some graded aggregates. When we talk about graded aggregates, we mean that these are aggregates or small bits of stone in varied sizes, so they're well graded. So all of these components have to be mixed in controlled proportions. Okay, controlled proportions, in other words, we have set mixes for different jobs. Categories of concrete are, number 1 there, dense. This is using aggregate of crushed stone and sand. This is the most common. And number 2 there, lightweight, using aggregate of blast furnace slag or expanded clay. These are just 2 lightweight substances that are also used sometimes for forming lightweight concrete units. There are links at the end of this lesson to a couple of articles, to a few articles, and these are the first 2 articles here if you want to read more information or get more information on blast furnace slag or expanded clay. You can follow those links at the end of the lesson. So let's have a look at each one of these components that make up concrete. So first of all, number one there, the cement. So cement is a matrix or a binder of the concrete mix. Ordinary Portland cement is made from burning 4 parts limestone, 1 part shale at 1500 degrees Celsius, which forms a clinker. So we burn these at very high temperatures, and then they form a clinker, which is kind of like a ball, a solid ball. The clinker is then ground up into this powder, this grey powder, and then gypsum is added in order to control its rate of setting. So gypsum is added to control the rate of setting. If we didn't add gypsum, what would happen is the pure ground powder from the clinker, once that gets hydrated or water's added to it, it would set immediately. So the gypsum controls the setting rate of the concrete. Cement is hydraulic in nature, so therefore it depends on water rather than air in order to develop its strength. Cement first stiffens or sets, and then it develops strength and hardens over a period of time. The key time for initial strength for concrete is 24 hours, then 7 days, and then 28 days. It only reaches its full strength after 28 days. The second component then that we need for making concrete is water. When water is added to cement, hydration begins. This is a chemical reaction which works faster at higher temperatures. So we have to be careful in sometimes if the weather is very hot, this can speed up the setting process, so we need to be careful if we're pouring concrete fresh on site if the weather is too hot. The water used should be fit for drinking, as demonstrated in the image opposite. Only a small amount of water is needed in order to hydrate cement. However, more is usually added on site in order to increase workability. So just to note there that really it's the minimum amount of water, and we should try and use the minimum amount of water when we're mixing concrete, because if additional water is added, what happens is this water evaporates, leaving voids, which can reduce the density, strength and durability of the concrete. However, depending on what application the concrete is going to be used for, we do need it to be the workability to be correct. So in other words, if we need to be able to level it out or be able to get a nice finish on it, then sometimes we have to add extra water. The third component then for concrete is aggregates. So aggregates should be free from significant amounts of impurities, so they have to be clean. Aggregates should be well graded, so therefore they should include suitable amounts of coarse, which will be any aggregate with a diameter greater than 5 millimeters, down to fine aggregate, which would be classified as any aggregate less than and has a diameter less than 5 millimeters. This is in order to allow minimum voids for filling with cement with the cement matrix. The maximum diameter for concrete is usually 20 millimeters. The well-graded aggregate allows easier workability, thus allowing a reduced water-cement ratio, letting the concrete achieve maximum strength. So we can get maximum strength by adding the least amount of water. If we're using the well-graded aggregate, it means that the concrete is more workable because the smaller bits, all the different size particles of aggregate, can move around each other, and it makes it easier to work with. Mixing and batching concrete. Mixing can be achieved through either volume batching. This is most commonly used on site, so using a shovel or a bucket, or weight batching, which is most commonly used in factories for precast units. Standard mixes for concrete on site are 1:6 to 1:8. That's 1 part cement to 1 6-part aggregates, or 1 part cement to 8-part aggregates, with a ratio of 0.5 for water, but this is depending upon the workability requirements. So worksheet question number 2. List the main components of concrete. stresses on concrete. If we have a look at the image down at the bottom of the screen there, that's actually a video that's being played at the moment of a shear strength failure test. So a load is being applied to this beam until to such point where the beam fails due to shear stress. In general, concrete in use is stressed in 3 different ways, and they are shear on its point of support, which we've just seen an example of in the video. And if we look over on the right hand side there at the diagram, we can see the other 2 areas where concrete is in stress. So the first one is shear, where we can see it's at the point of support, and we can see the red lines, diagonal lines there, showing how the concrete might fail. The second one then is tension. And the third one is compression. Tension is on the underside of the concrete, compression is on the top of the concrete. So when a load is applied, for example, to a beam like this one here, the beam tends to try and bend, and so the top of the concrete, or the top of the beam, concrete beam, is being compressed together, while the underside of the concrete is being kind of pulled apart in tension. Shear stress can be overcome by including reinforcing bars into the beam and at the point where the concrete is being supported. We have a look again now at the bottom of the screen here. We see this is another video of a tensile strength failure test. So again, a load is being applied to the top of the beam. You can see the beam bending there, and then they're going to apply this load until the underside of the beam is pulled apart due to tension, and we can see it breaking there. So concrete is strong in compression and weak in tension. Direct tensile strength is approximately 1/8 to 1/14 of compressive strength. So concrete is very strong in compression, but it's weak in tension. And so again, sometimes how do we overcome these stresses? We saw the example how we could overcome shear stress on the previous slide, and on this one here now, when we're talking about tension, the stress of tension on the concrete, sometimes what we'll do is we'll include reinforcing bars on the underside of the concrete, Another example here now of concrete strength. So we can see a sample of concrete there is being applied, pressure is being applied to it until the concrete fails. So this is the compressive strength of a cube or a cylinder test. So the strength of concrete is expressed in newtons, or more specifically newtons per millimeter squared. And this is a measure of the concrete's resistance to force. Standard strength of concrete for foundations and floors would be 30 Newton 20 or 30 Newton 10. Now the difference between the 30 Newton 20 and 30 Newton 10 is we have the 20 and the 10 stands for the largest diameter of aggregate that's going to be found in that particular type of concrete. So we have, first one is a 30 Newton concrete with the largest diameter aggregate of 20 millimeters. Second example there is 30 Newton concrete with the largest diameter of aggregate of 10 millimeters. And the reason we might want to reduce the largest diameter of aggregate to 10 millimeters is it would make this concrete more workable. And for example, if concrete was being pumped in a pump, then having a concrete mix with a smaller diameter aggregate would be a requirement. Concrete strength continued. For maximum strength, concrete should have 1. Suitable cement, aggregate and water, and we're talking about the minimum amount of water there. It should be thoroughly mixed and compacted. So it should be, all the materials should be thoroughly mixed together. And number 3 there, suitable temperature and humidity. So we don't want to be trying to pour the concrete when it's either very hot out or very cold, otherwise this can adversely affect the strength of the concrete. Block strengths, we're talking about the compressive strength of different types of concrete blocks. There are 3 different types of blocks and they're color coded. The standard grey concrete block would have a compressive strength of 5 newtons. Then we have a pink block, which we can see in the image down below there. which would be 10 newtons. That's stronger than the standard 5 newton block, twice as strong. And then the third type then is a kind of bright blue block, which would give us a compressive strength of 20 newtons. And the pink and blue blocks would be used maybe on high-rise buildings, or for building maybe columns or piers that are going to have large, going to support beams or heavy weights. Worksheet question number 3. Give a brief description of one characteristic of concrete. Concrete strength and workability. There are two common on-site tests that are used for concrete. The first is to assess the strength of concrete, and the second is to assess the workability of the concrete. The first one there for assessing the strength of concrete is called the cube test, or in one of the videos there a couple of slides back we saw an example of a cylinder of concrete being tested for its compressive strength. That's because over in the States they take cylinder samples, whereas in Europe here we do cube samples. The second one then is the slump test, and this is for workability. So I'm going to show you over the next few slides some short videos showing you how to carry out the cube test or cylinder test and the slump test.
Always give your cylinder just a light coating with form oil. I don't know, we got form oil inside, but just spray it a little bit with form oil. You don't want to pool form oil on the bottom of your mold though, just enough to, and if it does pool in your mold, take a paper towel and wipe it out. Fill in thirds. Use the small rod to tamp it 20 times. That. 25 millimeters into the underlying layer. How many I did there? I never really.
Go off the instinct, Kelly.
Yeah. And then just so it's overflowing.
So what would happen there is a random sample, or a sample of the concrete mix that's being used, maybe in pouring a floor or columns or beams, would be taken in the barrow we saw there, in the wheelbarrow, and then they take a sample of that and they create to fill up a cube or cylindrical mold. And we can see there how it's to be filled. It's to be filled in 3 layers, 3 even layers, and each layer is to be poked 20 times. And that's to try and make sure that there are no voids in it, so there are no air pockets in it. That's why it needs to be kind of, you can see him tamping it there to release any air bubbles, and also tapping it on the side just to kind of vibrate it there again to release any air bubbles, to make sure that it's fairly compact.
Close the voids. Use your trowel just to strike it off. The cylinder has to be finished so that there's no deviation of more than 3 millimeters at any given point in the cylinder. So you can't have pieces sticking up. It's got to be flat within 0 to 3 millimeters. Okay? So in other words, like that. Then you take your sponge, rinse it out, and then just wipe around the mold like this. Put the lid on, and then set it on the table.
So we can see here after the 3 layers of concrete are put into the mold, it's floated off on top, and then it's cleaned up as well, cleaned, because we need to keep these samples nice and clean. And what will happen with these then? These samples are cured over 28 days, so they're let go hard over 28 days, then they're sent off to the lab to be tested in the compression test that we saw earlier on a few slides back.
From the time you mix that to the time you complete your test, you've got 2 minutes to take your test. Put your feet on the cone like that. Fill your cone in 3 equal layers by volume, not by height.
So here we have the first of a few videos here just showing us the concrete slump test, which is for workability. The cube or cylinder test was for strength, to test the strength of the concrete, but this is to test the workability. And this will show us, for example, if extra water has been added to the concrete, because generally on site for larger jobs or for big pours, there'll be a requirement for a particular slump of the concrete. So you have a cone that's inverted and placed on top of a nice clean timber board there, level surface and flat surface, and then we have 3 layers of concrete are added, and again each layer will be tamped. We'll see now in the videos following.
So 25 times, equally distributed, fill it to the next level. 25 millimeters into the underlying layer, so about there. That. And then fill it so that it's overflowing somewhat. 25 mils into the underlying layer.
So each of the 3 layers are to be tamped or poked 25 times, and again this is to release any air bubbles that might be trapped in the sample.
There's no voids. Clean the loose debris around the cone, step off of it, and then in one motion pull it in 5 seconds. I'd rather see a slope than a short pull, so it's important. Set that like that, don't bump that. And then take the average reading to the nearest 5 millimeters. So you actually have to measure in 2 separate spots. You can't just take the middle. You actually have to spot, take the other spot, say the slump, 40 millimeters.
So once the cone is filled and the concrete's been cleaned off around it, then we pull the cone off as we saw in the video, invert the cone, and then we just put the cone beside our concrete, and then we put the poking rod across the top there and then measure down to give us our slump. Okay, worksheet question 4. Describe 2 common tests that are used for concrete. 2 common tests. So here we have the links to those 5 articles that were mentioned throughout the lesson there. So everything that you wanted to learn any more about each of these items, then you could just take a note of these links and type them into your address bar in your browser. So in summary then, in this lesson you covered properties of general materials used in construction, including concrete, which is used for foundations, floors and walls, etc. The main components of concrete are cement, which is the grey powder, aggregate, which is the crushed stone, and water, which has to be clean. And also 2 common on-site tests. We looked at the cube test or cylinder test for strength of the concrete, and then the slump test, which is for checking the workability of the concrete.